Okay, second last question. Monochromatic light from a helium neon laser with the wavelength of 632.8 nanometer is incident normally on a diffraction grating. So this is a diffraction grating containing 600 lines per centimeter. So that is 1 over n equal to 1 over 6,000. So we have to determine the angle at which the second order is observed. Firstly, let's calculate this. What do we call that? I don't actually remember what is MODI telling us. Okay, so that is the slit separation. So this is the slit separation. So this is gonna be 1.667 times 10 negative 6 meter. Okay, and then after that you would use this equation to calculate for the angle at which the second order is observed. Okay, so this question, it mentioned which order are we trying to calculate. So let us write that as 2. So substitute n equal to 2 and sine theta 2 is going to be here. So it's going to be 632.8 nano over the slit separation, which is 1.667 micro. Can rearrange that? So shift sign the answer of this equation, diffraction. So you should get the angle to be about 49.4 degree lah. Okay, so that is the angle at which the second order is observed. And then for question B, it asks us to calculate the number of maxima lines can be observed. Okay, so maxima lines is telling us that it is trying to calculate how many bright fringes can we observe on the screen. So for this one, we are going to use n to be less than d over d lambda. So it's going to be n 1.667 negative 6 over the wavelength 9. So you should have 2.63. So n is less than 2. So total maximum lines can be observed is around 2n plus 1. So n is 4 plus 1. So we can only observe about 5 bright fringes lah. Okay. Okay. I think you could also let theta to be equal to 90 degree if I'm not mistaken. Okay, so you could okay, assuming so yeah, if you were to calculate the maximum number of lines, you could use this formula here. Basically what I just did here is letting this degree here to be equal to 90 degrees. So sine 90 is equal to 1. Then you would get this equation here, da balik lah. Okay, so I'm gonna do it again lah. So the sine theta, so we're trying to calculate the number of maximum bright fringe that we can see on the screen. So this is gonna be d sine 90 degree equal to n max lambda. So n max is gonna be equal to lambda over sorry, kejap ha. Oh sorry, d over lambda. Okay. So if you get the value, you just have to plus 1 because we have to consider the central maximum. Okay, so we have to consider the central maximum lah, which is the middle, because that is also a bright fringe. Okay, but if it is the minimum lines, actually you don't have to plus 1. Okay, so that is on question number 9.